Welcome to Spring LIB.
So this question is asking us, well, they're giving us an equation for a wave, and this is going to be 6.5 millimeters, and then we have cosine of 2 pi x over 28.0 centimeters, and then it would be minus t over 0.036 seconds. And then they're asking us what are the properties of this wave, essentially: amplitude, wavelength, amplitude, speed of propagation, frequency, wavelength, all the properties. And one thing that we need to compare this to is the general equation. So we have the general equation for a wave, and this is going to be equal to a cosine kx minus omega t. So that means that in order to find the amplitude, it's really easy. This would be a is simply going to be 6.5 millimeters. You're just relating here to here. And we can convert this and say that this is going to be 0.00655 meters. And the wave number k, this is going to be this number here, is going to be equal to 2 pi over lambda. And in the equation, it's going to be equal to 2 pi over 28 centimeters. So this means that the wavelength is going to be 28 centimeters. So this would be your answer for part A, which is also includes the wave number. This would be the answer for the wave number. This is going to be the answer for part B, the wavelength. We can also say that this is going to be equal to 0.28 meters if you wanted to convert into meters. And then C is asking us for the frequency. And we know that the frequency is equal to the, the angular frequency is equal to 2 pi f, the frequency. And we know that the angular frequency here is equal to 2 pi over 0.036 seconds. And at this point, we can solve and say that this is going to be equal to 174.533 radians per second. And then we simply need to find the frequency, and the frequency is going to be equal to omega over 2 pi. This is going to be equal to 174.533 divided by 2 pi. And we have a frequency of 27.78 hertz. So this would be your answer for part C. Part A. Okay, and then now we're moving on to the speed of propagation. So we'll have D. The speed of propagation is found by taking the product of the wavelength and the frequency. We have both of these values, so we can simply do 27.78 hertz times the wavelength of 0.28 meters. That's why it's kind of beneficial to, instead of writing it down as 28 centimeters, write it down as 0.28 meters, because when we're trying to do any calculations, we're going to have to, of course, use SI units. And then solving this out, we find that the speed of propagation is going to be 7.78 meters per second. And then it's asking us E, where's the wave traveling? Well, we can see in the previous slide that we have a negative here, and in the equation, it's negative as well. But this being negative right here means that the wave is traveling in the negative x direction. And this is really just simply looking at the equation and comparing it to the standard equation for a wave, and seeing that, okay, this wave is going to be traveling in the negative x. And that's the end of the solution. Thank you for watching.